Hello everyone, today we're going to look at usaco-training home on the range. Okay, so in this problem we're given a large square field which is size n times n, and then on that square field some of the pastures on the field have been ravaged, and then out of those squares that haven't been ravaged, Farmer John needs to map um, some some squares where the cows can graze. Okay, so we have to report the number of possible squares that where the cows can graze. So for example, over here we're given n is 6, and here is the square passage, or square pasture. Square field. My bad. So over here 1 means that it's ready to eat, and 0 here means that it has been ravaged, meaning that a cow cannot graze there. Alright, so first thing is that since the cows only can basically graze on a specific square, it just means that it has to, or the width and the height has to be the same. Alright, so here is basically our output. So we're outputting 3 lines. Okay, so the first line over here means that there are 10 2x2 subsquares that we can make from this grid. So for example, if you take this square or this square or this square, all these 3 and the other 7 would all work. And for example, you can see that there are 1 4x4 squares, and that would be this, and this all combined together to make that square. Alright, so, and we have to order them ascending from smallest to largest size. Alright, so over here we're given that n is less than or equal to 250. Okay, so what we can do is that we can make dp of I and dp ij with equal to the maximum side of a square with its bottom right corner equal to ij. So what I mean is that, let's just say we have whatever grid, and let's just say this point is going to be ij. So then dpi would be some length over here. So the length of this would be dpi j. And since it's a square, then from here you would draw another segment up, and the length of this would also be dpi j. And then notice that when you draw this, you're going to form a square. And over here, the requirement is that all the numbers in between here have to be ones. So basically, all have to be ones. So all these have to be ones. And then we're just going to find the maximum site that can fit this situation. All right. So how are we going to calculate dp of ij? Okay, so first thing that we're going to assume here is that we're going to assume that that dp I minus 1 j dp I j minus 1. So basically, let me first write this down, I minus 1 and j minus 1. We're going to assume that these are calculated. Or basically, when we're calculating, or when we're calculating ij, basically all I less than, or I, let's call this x, j over here should be calculated. So basically, over here we have, over here at this point we have ij, so we're going to assume that the rest of the grid, which is above this point, is going to be already calculated. Alright, so now that we ensured that, we're going to try to make some transitions here. Okay. So right now, again, we have, okay, 1 second over here. We have, this is ij, and this is I minus 1 j. This is I minus 1 j minus 1. And over here, this is I j minus 1. Right, so right now we know that ij is unknown. We got this, and we also calculated this. Alright, so how are you going to basically apply this transition? Okay, so let's first look at this value. So we already calculated whatever we have for this dp value. So we're going to call this whatever we have, because we already calculated this, so we can already know which square would fit for ij minus 1. And then we're also going to see, let's use, since we also already calculated this, we also can see whatever square we have. So for example, we can have this. Okay, so let's actually first consider, or let's actually draw this like this. Oops. Alright, so over here, we draw here. Alright, so over here, you see that basically, okay, so now we're basically, let's first consider I minus 1 j and I j minus 1. So this is basically what we have for our dp values of dp I minus 1 j and dp I j minus 1. So assuming we have this, what we have here is that we know that right now, let's actually use, okay, so let's use blue here again. So we know that this portion has some zeros or something, because we know that there's basically a bounding line over here for our dp value. So we know that we cannot use this line. So then what we have here is that dpij will be equal to the minimum of dp I minus 1 j, since we know that this, because we want to have this specific minimum, and we also want to have this, or basically the distance over here, or basically just our dp values that we calculated previously. So then it would be equal to min dp I minus 1 j dp I j minus 1 and plus 1. And the reason we're doing plus 1 here is because that we're basically incrementing, because right now, okay, so you can actually phrase it like this. Okay, so we're assuming that here that we're not sure about this block over here. But right now, if we ensure that this block is equal to a 1, meaning that it can be taken, if we extend everything by 1, then our length would also increase by 1, since we're basically going from here, we're adding 1, and over here we have some. something like here, and we're also adding one here. All right, so that's the reason why we're adding one. Okay, so let's consider this DP state. And basically, you also need to make another state. So if aij is equal to 0, then dpij is equal to 0. Because if this is already a 0, then it means that we cannot make any any square that ends at ij. All right, so over here we have our states, but then for our last condition, let's actually erase this. Delete. Okay, I also have to put this here, and here. So let's get yellow again. So what if, let's go back here. All right, so what if for our dp I-1j, if it extends over here, then when we take the minimum of these, we're going to get what we have here, and then we're going to try to create a square that's over here. That's basically this size. Let's actually use a different color here. Alright, so we know that here this specific square is going to be the answer for dp I-1j. But then we're actually not sure about this spot over here. Because since this actually might be a big 0, then we cannot actually create such a big square. So then what we're also going to do is that, notice that we also have calculated dp, oops, so we also have calculated dp I-1j-1. And for example, if you see that from this point, we can only go on to some point over here, then if we can only go to some point over here, then it means that we cannot actually go all the way over here. So then over here, instead of just taking the minimum of dp I-1j and dp ij-1, we also have to include let's actually erase that. Alright, so over here, instead of having this, whoops, we're also going to include dp I-1, j-1, and then we're going to add 1 over here. So then, if we have something that starts here, and if it goes over here only, then we know that the rectangle that we're going to take is going, or I mean the square that we're going to take is going to be this, since it has the minimum value. And then after we calculated our dp values, how are we going to use this to find our answer? So surely we know that for each ij, so for each ij, okay, so we know that we can create a square from ij with length dpij. But then how are we going to apply this? So for example, if we calculated that at for example position 2, 3, we can have a square with length 2, then it also means that we can have a square with length 1. So let's actually draw another diagram here. Alright, so here is ij. So again, we have our dp value. So here's a square. So this is going to be the length over here. So we know that we can create a length of a square of length dpij. But if we can create a square of length dpij, we also can create a square with length dpij minus 1, dpij minus 2, dpij minus 3, and so on. So then what we're going to do is that we basically just have to update this into our answer because, okay, let's actually just phrase it like this. Okay, so we know that we can create a square with dpij. So then basically if we just cut this portion out, we're left with this, then we can also create another square. So then when we have dpij, basically for I from 2 to dpij, basically answer of, you would just increment answer of I, because you know that you can create something from 2 to dpij. And then after we're done, we just basically just print out what we calculated for our answer. All right, so let's just go for a quick review. So our dpij is going to be the maximum size of a square with its bottom corner as ij. So right now we have ij equal to this. All right, and then so again we're going to assume that all points before ij is going to be calculated. And now when we're calculating dpij, it would be equal to the minimum of dpi minus 1j, dpij minus 1, dpi minus 1j minus 1, and you would add 1 since you're creating a square with a new size. And also, here's an other case is that if aij is equal to 0, it means that you cannot create any square, so then your dpij will be equal to 0. And at last, we just basically update our answer after we're done calculating dpij. Alright, so let's get to coding. So, alright, so over here, we have n, the number of squares, and we also have a grid. So let's look at, so our maximum n is going to be 250. Alright, so then we have our grid. Let's actually call this A. So for I from 0 to n, let's actually use one indexing here. So we're going to read in a string ai plus 1. Right, so now after this, we're going to have our dp values. So our dp values are basically going to be 0 by default, and then to calculate them, we're going to loop through each I from 1 to n, each j from 1 to n. So if aij is equal to a 1, then dpij would be equal to the minimum dpi minus 1j, dpij minus 1, and dpi minus 1j minus 1 plus 1. Otherwise, dpij would be equal to, let's actually make this one a bit larger, would be equal to 0. Since if it's a 0, since you always have to use blocks with 1 in them, you cannot make a square with that. So then after this, we're going to have our answer. So we're going to for from k from 2 to dpij. We're just going to increment answer of k. So after this, so for I from 2 to n, okay, so over here I forgot to increment k. So from 2 to n, if we have something for I, then we're going to print f, 2 integers, I, and answer of I. Alright, so pretty concise. Let's run this. Alright, that's our input. Alright, 210, 3, 4, 4, 1. Looks good. let's open range.in, read, and let's open range.out, write stdl. So this is this is called range in the language. Alright, so let's submit this. Let's open this window a bit larger and select the file. Alright, so okay, range.cpp. Let's submit this. Ooh, typo, so free open. Alright, so yeah, I'm sure that's correct now. So my bad. Let's submit that. Alright, so everything is correct. If you have any questions, feel free to leave them in the comment section below. Bye.